Hello, I'm Mukund Kukreja, and I don't know how to do this, but yeah, I have been wanting to upload YouTube videos for a while now, just to experience how it's like, but I couldn't think of any topic to make videos on. So I thought, and a fact about me is that I am relatively good at explaining things to other people, things I understand well. When I say relatively good, I mean compared to other things I know, compared to other skills of mine. I don't mean compared to other people, other teachers out there. Of course, I'm not as good as them. But yeah, so that was my initial thought. How cool it would be to upload videos on YouTube teaching other people about the stuff I understand. But I didn't do that because my mind kept making excuses. Excuses like, I can't do this, I'm not good enough. There are so many other teachers in the YouTube space who can teach a lot better than me, a lot more intuitively, and in a much better way, much elegant way. I would never be able to compete with them. And honestly, I was I was lazy about it. I just didn't feel like doing it. But then it recently clicked with me that I shouldn't think about the competition. I shouldn't compete in the first place because I'm not a professional teacher and I am not trying to act like one. So there goes that excuse. Other than that, I changed my mindset, thinking of it in thinking of it as in teaching. No, let me rephrase. Rather than thinking of it as teaching, I can instead think of it as having a discussion or having just talking about the stuff that I have learned recently and sharing that to the mass out there. Yes, so here we are. And well, it's basically like I'm having a conversation with my best friend and telling him about all the things, all the exciting things that I just understood that I didn't understand before. So instead of calling it recently I learned, because those can be the things that I have just simply read or simply seen somewhere. I I decided to call it recently. Recently it clicked with me because these are the things that I actually understand now, not not the things that I have just read or seen, that I have read and seen and understood, and yes, that I have understand, that I understand now. So these are just couple of random things, absolutely random things. They may have connection, they do not, they may not have any connection with each other. There can be 10 number of things, hundreds, hundreds a bit much, but yeah, or there can be just two or three things in this video, in these video, depending on if I decide to do more of these. But yeah, so recently it clicked with me. Recently I understood. Keep in mind, these things are absolutely random. There is no structure to them, no order to them. They can be of any subject, anything. I need to get a pen. Wait. Recently it clicked with me that XOR gate, exclusively OR gate, XOR gate if you may, can be used as a conditional NOT gate. How so? Well, let me draw. If this is a NOT gate, a this is a NOT gate, right? Oh, it will be flipped, I forgot, but yeah, please try to understand. If we input A, we get A NOT without any condition. If we input A, we simply get A NOT. There is no condition. But in an exclusively OR gate, let me draw it. Here, and okay. This is a poor drawing, but I hope you understand. This is an exclusive OR gate. I know it's drawn poorly, but please understand. I will draw the truth table for it, which will be something like this: 1 1 0 and 0. This is the truth table for exclusively OR gate. So here, oh my god, this is flipped, but please try to understand. The B input, we are essentially flipping the B input if the A input is 1. So it's like, if the A input is 1, then flip the B input. If the A input is 0, just pass the B input as it is. So A input is 1, flip the B, we get 0. A input is 1, flip the B, we get 1. A input is 0, don't flip the B, just pass it. And with this also. And so exclusively OR gate can be used as a conditional NOT gate. Yes. If we want to flip the bits in a number, all bits in the number, we can connect all the bits with an exclusively OR gate and the other input of the exclusively OR gate with a condition bit. If that condition bit is on, flip all of the other bits. If the condition input is off, just pass it as they are. I learned this concept while studying arithmetic logical unit in the subject COA, computer organization and architecture, where if you want to subtract two numbers, we essentially take the first number and add it with the negative of second number, and the negative of second number is obtained by flipping the second number and adding 1 to it. So the process of flipping the second number uses these XOR gates instead of NOT gates, because we do not want to flip them all the time. We just want to flip them when we want to subtract the number. So there is a condition, and when there is a condition and we want to flip, we use XOR gate and not gate. That was the first thing. Now, speaking of COA, the second thing that I learned is what it means by computer organization and architecture. Well, there are many things in today's world which can be called a computer. So we won't touch on that because I don't clearly understand that part of it myself. But recently I learned the difference between organization and architecture. So architecture deals with the things that the programmer actually sees, like, and organization deals with the backend part of it, how it's implemented. For example, the programmer can see there is an opcode method to multiply two numbers. Let's call it MUL. So if we write mul A and B, the programmer understands that opcode will multiply those data. That's the architecture part. The organization part will deal with how this opcode works. So we can create a whole circuit for multiplication, or we can use the addition circuit in a loop to essentially multiply two numbers. So basically that's the difference. The architecture part is the thing we actually see on the front, and the organization part is the back end of it, how it's implemented. Other thing that I learned, which is Probably very basic thing for most people out there, but I didn't understand it this way before, but I do now. Wait, there was background noise, so I have to pause, but yeah, I'm back. Yeah, I was talking about the thing I recently understood. Very basic thing is when we talk about cores in a CPU, core, C-O-R-E, core in a CPU, like octa-core, quad-core, we say for a processor chip. The core in that processor chip is essentially a CPU. It's a CPU. The chip is called a processor chip, inside which there are many cores, and each core is a CPU on its own. That is, each core has its ALU, its CU, its internal buses, etc. Each core has its own, and there are so many cores in one single processor chip, which is about this size. How mind-blowing is that? Each processor chip has multiple cores. Every core has multiple ALU, CU, buses. Every ALU and CU has its own components, own smaller components, AND gates, NOR gates, all the logic gates, and adders, subtractors, all these circuits inside them. So this much of chip comprises of so many things that is absolutely mind-blowing for me. Yeah, I learned that recently. Speaking of buses, that's another thing I learned recently. So that's the fourth thing. There are buses in many places of the CPU or the processor or in computer organization. There is a system bus, there is an internal bus. That much I know right now. Maybe there are more. But yeah, the system bus is the bus which deals with the data transfer between the main memory, the CPU, and the input output devices. And then each CPU, each core has its own set of internal buses which deals with the data transfer and instruction transfer between the ALU, the CU, and the cache, all the internal components of a CPU itself. So that's that different type of buses I didn't know before. I thought there was a whole single bus, a single set of wires for data transfer between everywhere inside a computer, but that was not the case. These are the only things I could think of for this video. I'm sure I learned much more, but I forgot that I cannot simply recall right now. But yeah, maybe next time. Also, please keep in mind that I could be wrong about all these things, as I am only currently learning about these things. And as you can see, most of the things, actually all of the things were related to computer. Yeah, that's my field of interest. I'm currently very invested in the subject computer organization and architecture. I'm finding it very interesting and exciting, so I keep on learning about it. I think that's all. I don't know how to end the video. Let me think. Was there anything I wanted to say? I guess not. Yeah, if I feel ah, by the way, I keep looking down here and then up there and down here and up there, because this is actually my first time filming myself in a video like this, so I don't know if I should look at the screen of what actually is recording, or if I should look directly into the camera to make eye contact. So that must be awkward, but yeah, please bear with me. I will get good at it with time. And another benefit of making these videos, if I decide to make more, will be the improvement in my English, because well, I am relatively good at English grammar and writing English, but I am not so good at speaking it, especially not I don't have much vocabulary to work with. So yeah, I want to improve upon that as well, and I want to just try out new things. So this is the video, and okay, let me just stop here. I will continue in the next video. Thank you for watching. I guess I am not really making it for any other people, or I don't know how to phrase it, but yeah, I'm essentially making it for myself because I'm enjoying this process. Okay, let me stop. Bye.